6-2 was about multiplying and dividing radical expressions. We worked problems 2 through 8, 10, 11, 15, and 16, 19, and 20. 1, 2, and 3 says multiply if possible, then simplify. To start, identify the index of each radical. So, number 1, they've done, let me separate these. Number 1, they've started, so it's a cube. So, because both of the powers match, cube root, then we can just combine that into one radical. So now we can take that, say, well, what's the cube root of 24? And actually, we didn't even work this one. So, sorry. Let's go to number 2. We have the square root of 5 times the square root of 8. The index match, so we can combine those into the square root of 40. And we can rewrite 40 as what? The square root of 10 times 4. And we can rewrite 4 as a perfect square, 2 squared, right? So that's like saying the square root of 2 squared times the square root of 10. And 2 squared comes out as 2. So it's 2 radical 10. And that's your answer. And here, the powers, the index is not the same, so you cannot multiply. Okay. The next problem, simplify. Assume all variables are positive. To start, change the radicand to factors with the necessary exponent. So that necessary exponent must be equal to your index. So we've got an index of 3, so we want to rewrite this radicand as factors with exponents of 3. So we've got 27, which we can rewrite as 3 to the 3rd power. And then we can rewrite x to the 6th as x squared to the 3rd power. So now that we've done that, if you want to break them up, it's 3 cubed times the cubed root of x squared cubed. So all of those cancel out to 3x squared. And that's your answer. Okay. Next, we have 48x cubed y to the 4th. Well, there's no index, so we know that's assumed to be 2. Right? So we want to rewrite 48 as factors that we can square. So 48 is 16 times 3, right? And x cubed, we can rewrite that as x squared times x. And y to the 4th is y squared squared. Now 16 we can rewrite as 4 squared, right? So now let's split this all up. Square root of 4 squared times square root of 3 times square root of x squared times square root of x times square root of y squared squared. And now these cancel, so we have a 4, and we're going to have that left over and that left over. So let's do all of our squares. X, and then those cancel, and we have a y squared times the square root of 3 times square root of x, which we'll just combine back. So this is our answer. Okay. Oops. Let's see if I can group this. Number 6, we have did we work that one? Let's see. Okay, number 6, I've started here. We've got the fifth root of 128. Well, 128 can be written as 32 times 4, and we know 32 is 2 to the 5th power. So we're trying to get those in factors of powers that match our index. Right? So then x squared, and then y to the 25th is y to the 5th power. 5 times 5 is 25. So now we can split these up. Equal. And I'm going to put my powers. So 2 to the 5th times the square root of 4. And I'm going to leave that 4x squared together because those are going to stay the same, times the 5th root, and all these are 5th roots of y to the 5th power. So this comes out as 5, whoops, excuse me. Two to the 5th power. Oops. These cancel out, and I'm left with the 2. And this y to the 5th power leaves us with y to the 5th. And then we're left with the 5th root of 4x squared. So this is our answer. That's 5th power. So it's 2y to the 5th times the 5th root of 4x squared. That's easier to read right there. 7 and 8, multiply and simplify, assume all variables are positive. So because our index match, we can just combine 12 times 3, so square root of 12 times 3 is square root of 36. Square root of 36 is 6. And 8, we've got equal index here, both match, so we can just combine. So it's going to be 7 times 32, which is 224. This is going to be the 4th root. And then x to the 6th times x squared. Well, you just add the powers. When you multiply pairs of the same base, add the powers, keep the base. So x to the 8th. Now we need to rewrite this in factors of powers who match our index of 4. So this becomes 16. Let's see, the 4th root of 16 times 14 times x squared to the 4th power. And 16 is just 2 to the 4th power. So let's rewrite this. So it's going to be the 4th root of 2 to the 4th power times 14 times x squared to the 4th power. And all of these things with the 4th power we can take out. So the 2 and x squared will come out, and what's left over? The square root of 14. I'm sorry, not square root, the 4th root of 14. Okay, and that's our answer. (11) says simplify each expression, assume all variables are positive. So because our powers match again, we can combine these. So let's combine the outside first. 5 times 2 is 10. Now this is going to be a 2 times 2, which is 4. X times x cubed is x to the 4th. And y to the 6th times y is y to the 7th. Okay? Now our next step is to break it up in factors of powers that match our index of 2. So our next step, we're going to have that 10 still, square root of, and this is going to be a 2 squared, and x squared squared, and this is going to be like y to the 6th times y, and we can rewrite y to the 6th as y cubed squared. So I'll just do that here, y cubed squared. Right? Now all the things that are square we can take out, so leave our 10 here, and we still have a 2 squared comes out. Oops, let me fix this. And the x squared comes out, and the y cubed comes out. And we're left with the square root of y. Now let's clean all this up. So 10 times 2 is 20, x squared y cubed times the square root of y. And that's our answer. (15) and 16, divide and simplify. Assume all variables are positive. To start, write the quotient of roots as a root of a quotient. So notice that because both of these index are the same, we can combine it under one radical sign. So now that we've done this, let's just go ahead. 9 goes into 36. Actually, let's split it up and I'll show you. 36 over 9 times x to the 6th over x to the 4th. Right? And now 36 divided by 9 is 4. And that's going to be x to the 6th minus 4, which is 2x squared. So we have 4x squared. Well, 4 can be written as 2 squared. So we've got everything in factors of 2. So we've got 2 squared times square root of x squared, right? So you can take that out and that out. So we have 2x is our answer. 16. Now we're dealing with an index of 4. They match. So let's just go ahead and combine them under one sign 4. So 100, whoops, excuse me. 405 divided by 5 times x to the 8th over x cubed times y squared over y squared. Okay, and we know that's going to simplify to just 1 multiplied by 1. So basically that disappears. Well, 5 goes into 405 81 times. So we have the 4th root, so that simplifies to 81, and this is going to be x to the 8 minus 3, or x to the 5th times 1. So anything times 1 is 1. Now we need to rewrite these in factors of powers of 4. So we've got the 4th root of, and 81 is just 3 to the 4th power, and x to the 5th is x to the 4th times x. So now these things that have a 4th power we can take out. Right? So our final answer is 3x times the 4th root of x. And that's your answer. Last, we're working with 19 and 20, and it says rationalize the denominator of each quotient. Assume all variables are positive. To start, multiply the numerator and denominator by the appropriate radical expression to eliminate the denominator. So we want to eliminate this. So notice that that's a cube. So how could we eliminate the cube of 2? Multiply it by 2 squared, right? Because if we have, or the cube root of 2 squared, right? What would that give us? It would give us the cubed root of 2 cubed, and then it clears it, see? But if we multiply the denominator, we must also do it to the top, 2 squared. So we know that's going to clear and give us just a 2. And on top, we're going to have 2 squared x, which is just 4x. So we're going to have the cubed root of 4x. And let me clean this up, and then we've got our answer. So we've got on top the cubed root of 4x over 2. And that's your answer. It's that easy. Our last one, 20, we've got 7x to the 4th y, the square root of 7x to the 4th y over the square root of 5xy. Well, they're both squares. So let's clear the square down here. So all we have to do is multiply it by a 5 and an x and a y, and that will clear all those squares. Oops, multiply times the square root of 5xy, and then we also have to do it to the top. Right? So that would clear our sign. And on the denominator, we're left with 5xy. And on the top, let's combine them. 7 times 5 is 35. X to the 4 times x is x to the 5th. And y times y is y squared. Well, we can still clean this up a little more. Oh, I left my pause on when I finished the problem, so I'll just scroll down and show. I don't know at what point I left off, but when you simplify this 35x to the 5th y squared over x 5xy, well, breaking it up, the x to the 5th becomes x squared squared times x, and y squared is square root of y squared. So what comes out is x squared y out here, and you're left with square root of 35x over 5xy, and then you cancel out your x and y's, and you get your final answer is x times the square root of 35x over 5. And there's my work. Okay, thanks for watching.